Greetings, friends. You probably already know that airships are taking to the skies again. And one of the most common questions I hear is about their safety. And indeed, this is a relevant and important topic, especially when it comes to passenger transportation. Many people still remember the tragically famous Hindenburg, so this topic deserves special attention. So, let's talk about this honestly, objectively, and to the point. I'm Gennady Babanin, and this is the podcast, in my own words, about new generation airships, their technologies, their missions, and of course, their safety. To understand how far we've come, let's briefly go back to the past. The famous Hindenburg was a technological masterpiece of its time. And I want to really emphasize that it utilized hydrogen, a highly flammable and incredibly volatile gas. Despite all the extensive safety measures that were meticulously taken, it still wasn't quite enough. But that didn't stop it from successfully completing more than 60 transatlantic flights before the well-known and tragic incident. However, the catastrophic disaster that occurred in 1937 profoundly shocked the entire world and subsequently became a pivotal turning point in the history of airship construction and design. Even then, however, the airship was equipped with fire suppression systems, fire-resistant materials, and leak detection controls, but the technology of that era simply didn't allow for anything more. So, what has changed? In the 21st century, airships are experiencing a revival, but now with a different philosophy. Safety is now being restructured not just based on experience and intuition, which people had to rely on in the past for certain issues, but on precise data, engineering models, and constant real-time monitoring. What solutions are in place today to safeguard the safety of airships? First of all, it's the use of helium instead of hydrogen. Helium is an inert gas. It is not flammable. A scenario like the Hindenburg is simply physically impossible. This gas does not burn, period. I hope this settles the matter, because I keep encountering misconceptions about it. Second, there are durable composite envelopes. They are resistant to punctures, they do not burn, and they retain their properties even under significant temperature fluctuations and external impacts. A multi-level system of pressure, temperature, and humidity sensors monitors every zone of the airship around the clock, 24/7. Advanced software algorithms that control almost all onboard systems, from balancing the craft to emergency landings. Modern safety valves that effectively and reliably stabilize internal pressure and completely eliminate the possibility of the envelope rupturing from the inside. Sophisticated electrical systems with multi-level protection and automatic shutdown in case of an electrical overload. There's also an advanced autopilot system and much more. So, why are airships objectively safer when compared to other types of aircraft? Let's compare. If we look at airplanes, when the engine fails, they basically turn into gliders. They can only keep flying thanks to inertia and their aerodynamics, gliding through the air in the hope that the pilot can find a suitable place to land. Everything depends on the circumstances and the skill level of the pilot. But if the aerodynamics are compromised, for example due to loss of control or damage to one of the wings, the plane will simply plummet to the ground under its own weight. If we consider a helicopter, in the event of engine failure, it can enter auto-rotation mode, again, provided that all its blades are intact. This gives a chance for a controlled landing. However, this is an extremely difficult maneuver that requires exceptional training and favorable conditions. If the blades are damaged, the helicopter simply becomes a falling piece of metal. But what happens with an airship? Even if all electronic systems and engines completely shut down, it doesn't fall, it simply descends slowly and smoothly, all thanks to its aerostatic lift. And this isn't magic, it's physics. The helium inside the envelope keeps the craft aloft, regardless of whether the engines are providing thrust. This is a fundamental advantage of the airship. It is inherently stable and safe. This means that even in the event of a serious accident, people on board still have time and an opportunity to be rescued. In extreme situations, this is critically important. It's one of its main key advantages, both for passenger and cargo transportation. Just imagine how many lives such a simple feature could save in the event of an accident or emergency. Of course, you can't just say, "We have helium, so it's safe." Of course not. Safety is a systematic approach. It's a well-thought-out architecture where everything is interconnected. The design, materials, algorithms, operational protocols, and staff training. All of this is built upon the very same fundamental principles and established protocols that are still widely used today in modern aviation, space technology, and other critical areas of air transport. We meticulously use proven engineering practices, carefully integrating standards adopted in other aircraft and thoughtfully adapting them to the specific requirements of aerostatic vessels. In our new generation airships project, we are implementing exactly this kind of systematic approach. We consult with leading experts, model dozens of scenarios, and implement multi-stage checks. This is work for decades ahead, and we take it seriously. Friends, the world is changing, and airships are changing with it. They are no longer just a romantic symbol of the past. They are real machines of the present, systematic, technological, and safe. And if you still think that an airship is unsafe and just a big, vulnerable toy at the mercy of the weather, I recommend watching this video again. We are building transportation that will be safe by default. That's all for now. All relevant links are in the description. Thank you for being with us and staying with us. See you next time.